Welcome to our exploration of Go's type system. In programming, types define the kinds of values you can work with and what you can do with them. In Go, this concept is central, ensuring that your code is both robust and predictable. Let's dive into the types available in Go. Let's look at a practical example using Go's math floor function. This function rounds a floating point number down to the nearest whole number. In our code, we call math floor with the value 2.75 and print the result to the console. When we run this code, the result is printed to the console. The math floor function rounds 2.75 down to 2, and that's what we see as the output, rounded down value, 2. This confirms that the function is working as expected. But what happens if we pass the wrong type of value to the math floor function? In this example, instead of a number, we're passing a string. Since math floor expects a number, this is going to cause an issue. When we try to run this code, Go immediately raises an error. The error message indicates that we cannot use a string where a number is expected. This demonstrates Go's strong type-checking capabilities, which prevent such mistakes from slipping through. To better understand how Go handles types, we can check the type of a value using the reflect.type of function. Here, we're passing 2.75 and printing out its type. When we run this code, the output tells us that the result is of type float64. This matches our expectation since 2.75 is a decimal number. Understanding the types of your values is crucial in Go programming. Go is a statically typed language, meaning it checks the types of all values before running the program. This type safety helps catch errors early, ensuring that your code behaves as expected. In Go, using the wrong type results in immediate feedback, preventing runtime issues.